Hello, my name is Alan. I'm come from the AccelStor, Taiwan. AccelStor comes from two words, acceleration and storage. We intend to develop with very high-speed storage. So we do not want to replace everything, but we had to replace with the bottleneck of the storage. We're just 2 years old and a startup company, and we have two design houses. One is in Taipei. It's mainly for the system level. We're doing the UI design and the fiber channel, the SCSI. The other will in the Hsinchu, was mainly focused on with Flash management system. Although we are still young, but we already have won several awards. One is one of the 10 coolest storage startup company in 2015. The other is the 20 most promising HPC solution provider last year. Okay, what we are doing right now, we are doing the all-flash array. Okay, we are not using the traditional array algorithm. We have the fully dedicated algorithm for the all-flash. And we provide the high performance stuff from the 300K IOPS and up to previously with 700,000K, but the latest model will be the 700,000 IOPS. For the 4K render write, which is the very hard to achieve performance. And we provide the low cost of ownership because we use the commodity design, which is a 2U, 1U standard design, and a 2.5 inches of SSD. So you can save a lot of the effort to provide the high performance, but also affordable price for you. And we do have the several connections for you. For the industrial is the 10G SP Plus, and we have to have the InfiniBand, FDR for many for the HPC, and also, of course we have the fiber channel at 16Gs. Last year, we attended with the FMS, Fresh Memory Summit in Santa Clara, California. We have one best of shows. And in the flash industrial, that is every vendor will show the capability and achieve in this meeting. And we do have the good time right here. And last year, we co-with Data Core, okay? That is the software storage company. They provide some certifications. We co-work with them to get the data core ready certifications. And this year, we also certify with the SMPA for the HA models. For the OpenStack, we do have some kilo version center for engagement for certain projects. And we do engage with the Tiger technology for many for the fiber and share solutions. VMware is the main target for the virtualizations. We have several models have the VMware ready and VA block certifications. This year in January, we already get the rank 3 in the SPC-1 price performance ranking, which means that we provide a high performance and also affordable models. In our product, we use the Melos technology a lot. One is for the HPC. The other we're using the InfiniBand for the HA model for the data synchronizations. Why AccelStor? Okay, we are using the software to boost with the hardware performance. Okay, so we use very efficient technology to try to transform the inbound data, random data into the sequential before right into the SSD. So the performance is remarkably very high. Can go to the 700,000 subset 4K random write. And we have several models from the 1U to 2U. 1U, we have the 8-bay, 10-bay stuff on the 300,000 IOPS. And by adding with the SSD, we can increasing with the performance. So the software itself is not a bottleneck. We do have some data protections. So we are not using some kind of the striping, but we provide the proprietary to protect the data solutions. And we divide into two groups. Each group has one parity, which means that they can fail in one single drive. And when the group is failure, it will automatically dispatch to another groups. Although we're using the enterprise SSD, the DWPD may be 3, but the write time for the MLC probably 3,000 to 5,000. So we should take care about the write behavior. By using the global ware library, we can easily write into the single SSD to make sure with a system-level reliability. And it's affordable. As I mentioned before, we use the commodity hardware and using our software to boost the performance. And let's take a look with the advantage with the FlexiRemap submit, FlexiRemap over the RAID. Okay. So right now we don't use the cache. So which means that when we're testing with the different kind of the method for the RAID, we just turn off the cache. And actually, our algorithm is not using the cache. Okay, we compare with the software RAID 5.0 or hardware RAID 0. For the mass performance, I think in the industrial, probably they can reach up to 100,000 IOPS. But we can using our algorithm try to boost with performance up to 1 million. And we use the TPC loading and try to use the SQL workload for testing with the write behavior. So as you can see in the RAID bar, okay, the first drive and two drive is overwritten by the algorithm. Compared with the, our algorithm is evenly write into the SSD. So in this scenario, it can make sure with the system level reliability. Okay, let's continue to compare with the RAID. Okay, and by the endurance, okay, the total by written TPW FlexiRemap is can up to 4.8 petabyte, but the RAID is less than 2.8. Because that some of the RAID system, they are not considered with the write behavior. They try to modify and try to easily doing the program erase cycle to try to avoid the write behavior. And for the system lifespan, our system can up to 4.5 years, and the RAID probably going up to 1 year, the drive will going down. And write amplifications, we are 1.3, and of course RAID don't do the customization for the write, so that is 2. And we do using the data-aware recovery. That is mainly for the HA. We're using the InfiniBand to synchronize with 2 controllers. Okay. Without using the data-aware, that will probably take about 200 minutes to synchronize 2 controllers. But if we're using the data-aware recovery, we can take about less 5 minutes to do the synchronize. Or if we synchronize with the data only, they'll take about 40 minutes. Neo Sapphire P710 is our latest model, which is the high performance up to 700K IOPS, 4K random write with data protections. And there is 2 features that I had to mention before is the free clone and redirect on write snapshot that we can talk about later on. And they still have the snapshot backup, restore, and VMware certification VAI block. That is the normal situation that we're doing the snapshot redirect on write. Okay. Once the data is going to write, they will try simply using the logical volume, try to use the pointer to add with the change block. As you can see that in 1 o'clock, 2 o'clock, there's difference only with D. So logical volume only changes table and adding with the block D. And compare with other algorithms, we're using the copy on write, okay, especially for the ZFS. They were trying to protect with the modified block and try to copy to the another block and try to modify, which has an extra 1 read and 1 write. So compare with redirect on write, we can reduce one read and one write. And actually that we're doing the mapping, so once the snapshot is only allocate with the change block, not everything. So it's very efficient for the use of the database. So Snapshot is doing the local backup, and of course that you can backup with the Firebase, the image into the remote system. So of course you can use some of the NOS or disarray interface using the NFS or CFS to do the backup. And this model has the vSphere web client plugin, which means that once we install with this plugin, we can control and to create, delete, and clone the data store in the vSphere. Without this, you probably should get back and forth, try to configure with the storage, volume, iSCSI, and go to the vSphere to try to hook up with data store, back and forth to do this kind of scenario. But if you're using the plugin, you only can focus on with the vSphere to doing this kind of jobs. Free clone is mainly for the virtualization applications. Okay, so this is a very typical VMware scenario. You try to get a lot of guest OS, such as Ubuntu, Windows, and CentOS. Sometimes the system admin want to try to create a testing environment, so that they probably using the clone to doing the Windows Clone 1 and Clone 2. By using this kind of free clone technology, we just simply point out with the original space. So in this time, there is no allocated physical space. Unless that user try to log in and try to run with the user space, we will have the occupy with the physical space. And we do have the HA model. 3706 is the share nothing architectures. It's the 2U 34-bit design and has two controllers. Each controller has the dedicated storage, so there is not shared storage anymore. And each controller has the CPU RAM, so it's no single point of failure. And we provide the symmetric active failover. Okay, so I will talk about the another kind of the vendor, the solution right now. So the common symmetric active HA, we so-called ALUA. Actually, that is HA, but they using the shared storage pool. Okay, in that means that they were using the iSCSI protocol, the PR, persistent reservations, for the protections. Once the controller A is failure, okay, they try to unmount with the current shared pool and try to hook up with the controller B, which is take a lot of time for the failover. As I can see in the industrial, almost take 5 minutes or to 60 minutes. And the other risk is once of the single storage pool is failure and all the data is gone. Our solution is using the symmetric active HA, okay, which has the software-defined controller has its own dedicated storage. Okay, so we have the storage node A and the storage node B. And applications can go into the multi-path, try to doing a round robin or failover, try to write the data into our storage. And then our storage, we using the high-speed communication. We use the InfiniBand, try to synchronize with two storage nodes. So in this way, once we do have the performance improved, and then we can have the redundant happen. It is the, I take a picture from the rear panel. So as you can see that there is a two node in the 2U chassis. And each U has the storage with dedicated storage. And we can use the either the failover or round robin method to doing the this kind of implementation. VMware default is using the MRU, and probably you can choose and change with the round robin to increase with overall redundancy and of course the performance improve. Okay, for the applications we choose 4 category. One is the VM VDI. So the infra is very typical usage for the VMware. We provide some the iSCSI or fiber channel. The VM ESSI can hook with our search as a data store, and then can try to install with the guest OS. For example, if we provide with the 400K IOPS storage, and we try to install with a guest OS, and each KOS can occupy with up to 50K random write IOPS. So that is typical for the server storage kind of view, but the storage, if you provide high performance IOPS, you can try to install in our official array. The other kind of solution is VDI. The typical solution will be the VMware horizontal view. Okay, so once you use our official array, you can save another VDI deployment time. Another thing is the boot storm. Once the typical is that university, they try to log in with to VSI between class to class, because that each class has a different kind of usage for the OS. So once they want to put up from the class 1 to class 2, they take a lot of time, because that every student try to log in and try to put up with the system. And with the FA, they can reduce the boot storm, and as our testing, we can put up to 500 VMs within 5 minutes. Okay, the system is put up, and you try to log in with the system. They will create a profile and try to create the local storage, which so-called the local storm, login storm. So in this way, it can also improve this kind of by using the FA. The other typical usage will be the database. Okay, in the database that they don't use the IOPS anymore. They were using the transaction per minute or transaction per second. Right now, we use the industrial standard HammerDB as a benchmark. The left-hand side, we use the local 20 local drives, and it can reach about 500,000 TPMs. By using our official array, we can easily reach up to 2.3 million TPMs, which is very huge difference. And third category will be the HPC. We take with the parallel file system Lustre as an example. Lustre is open source, okay? And probably 2 or 3 years ago, Intel take this as a solution and try to put into the support team and try to make a fancy UI. Okay, so here is we are take a benchmark with the SAS 15,000K HDD with 16 nodes. Okay, the total drive will be 240 pieces. So they can generate with the random write around 3,700 megabytes per second. Okay, so we are using the 3 nodes. 30 pieces of SSD can easily generate up to 6,300 megabytes per second, okay, which is the 2.5 performance difference compared with the SAS high performance drive. On the other hand, you can also save a lot of space for the rack mount cabinet compared with the 6 node and the 3 node. And other kind of things will be the power consumption, heat, resolution for the air conditioner. We do provide full range of the official array. Okay, so the connectivity is from the 10G InfiniBand to fiber. Okay, so we also list our performance 4KB random write as our spec. So it's already tested with the 100 hours subtain test. So from the 360K IOPS to the 700,000 IOPS. And we list with the usable capacity, which is different kind of the calculation compared with others. That is not a row, okay? So the array is already initialized and ready to use. So as you can see in the volume, they're already there. The file is guaranteed, 100% guarantee for the usable capacity. And we also list with the endurance, the TPP, and the lifespan. And right now we select with enterprise SSD. And probably many will be the 3D.PD. So here is my presentation. Any questions? Okay, thank you.